Ever work on a software project where everything runs perfectly on your machine but then crashes and burns everywhere else?
Oh yeah, the "it works on my machine" problem.
Right, like trying to fit a square peg in a round hole. But someone invented this almost magic hammer called Docker to fix that, which is what we're diving into today using, the research you shared.
Good analogy, actually. Docker did kind of revolutionize how software is built and shared. Like, standardized shipping containers changed global trade.
Okay, let's unpack that comparison then.
Yeah.
Our source keeps using it, so it's got to be important.
It is. Imagine the chaos before shipping containers. Different sized crates, fragile goods just thrown onto ships, inefficient and messy. Then boom, standardized containers. Anything could be packed neatly into these uniform boxes, easily stacked, transported, unloaded, anywhere.
So Docker is like a standardized container, but for software.
Exactly. Instead of physical goods, we're talking code, libraries, dependencies, all the stuff an application needs to run. Docker bundles it all into one self-contained unit. A container.
And no matter where that container goes, my laptop, some massive server, the cloud, even that application just works.
Yeah. Because inside, it's like its own little world. Everything's pre-configured. No more compatibility issues, no recreating specific environments.
It's like no more, it works on my machine excuses then.
That's got to be a relief for developers. I think our source material said this makes development cycles way faster.
Yeah, before Docker, developers spent ages setting up environments and debugging compatibility issues. Docker streamlines that so they can just focus on building great software.
Like going from, I don't know, a horse-drawn carriage to a high-speed train.
Something like that. And it's not just good for developers either. The whole software development lifecycle is faster, meaning companies get products out quicker and more efficiently.
This is making a lot more sense now. You've explained that really well. But I do wonder how the container magic happens. Our source mentions images and Docker files. What are those? Okay, so let's stick with our shipping container example. When you pack a container, you wouldn't just throw stuff in randomly, right? You'd have a plan, a blueprint.
Right, makes sense. So the image is like the blueprint for the container.
Right. The Docker image is a template. It's got all the instructions for creating a container, specifies the operating system, the software, the libraries, everything needed for a fully functional runtime environment.
The image is the plan. Okay. What about the Docker file then?
Think of the Docker file as the instructions telling Docker how to build that image, like a recipe that lists all the ingredients and steps to create that perfectly configured environment inside the container.
So the Docker file is like step 1, add Linux. Step 2, to sprinkle in some Python.
You got it. It's a script. It automates the process of building an image, and that's where things get really powerful. Once you create a Docker file, you can share it, and other people can recreate that exact same environment on their machines with one command.
Like sharing a recipe. Everyone uses the same instructions, ends up with the same thing.
Exactly. And just like you wouldn't bake a cake from scratch every single time, developers use pre-built images to save time, and that's where Docker Hub comes in.
Oh, Docker Hub. Sounds like that could be our next stop on this deep dive.
Yeah.
Docker Hub. Sounds like some central hub for everything Docker, right?
Exactly. Think of it like a giant library.
Yeah.
But instead of books, it's full of Docker images, ready to download and use.
So like the Library of Alexandria, but with software blueprints. Pretty cool. What kind of images are we talking?
Anything, really. Images for languages like Python, Java, images for databases, MySQL, MongoDB, web servers like Nginx, Apache. You can even find images for entire application stacks, WordPress, Drupal, you name it.
Hold on. So instead of spending like hours setting up a web server from scratch, I could just grab a pre-configured image from Docker Hub.
Exactly. It's like ordering takeout instead of cooking a gourmet meal from scratch every time. Saves a ton of time and effort.
That's incredible. Like having a team of chefs ready to go at a moment's notice. Which reminds me, our source mentioned Docker being super efficient, especially compared to older technologies like virtual machines.
Yeah, big difference. Before Docker, if you wanted to run an application in isolation, you would often use a virtual machine.
Virtual machines.
Yeah.
Like trying to ship those old mismatched crates we talked about. Kind of big and clunky.
Good analogy. Virtual machines are like those giant cargo ships. Each VM needs its own operating system, takes up a lot of resources, makes them slow to start.
So you're launching a whole new operating system just to run one app.
Pretty much. Not very efficient. Docker is more like those nimble container ships. They share the host operating system's kernel, which makes them much more lightweight.
So instead of resource-hungry ships, we have efficient container ships that can share resources and move around independently. Pretty clever. And since containers are lightweight, they're much faster too, right?
Oh yeah, Docker containers can start up in seconds. Virtual machines, minutes. This speed and efficiency make Docker perfect for modern development practices. Things like continuous integration and continuous deployment, CI/CD.
Our source mentions CI/CD. Docker plays a big role there.
Huge. Imagine you're on a team of developers. Every time someone changes the code, you need to make sure it didn't break anything. That's where CI/CD comes in. It automates building, testing, and deploying software.
So it's like having a quality control team that checks everything before it ships out.
Exactly. And because Docker containers are portable and consistent, they're perfect for CI/CD.
Streamlines things. You mentioned consistency. How does Docker make sure applications run the same everywhere, even with all these different environments?
It's the images. An image has all the dependencies and configurations an application needs, so it'll run the same on your laptop as it does on a server in a data center,
Magic button that recreates your environment anywhere.
basically. And if there are issues, Docker makes it easy to roll back to an earlier version of your application.
Rollback. Like hitting undo on a bad software update.
Yep. Docker tracks changes every time you create a new image. So if a new deployment goes sideways, you can just instantly revert back to a working version, minimizes downtime.
That's a relief. No more late night debugging sessions. Docker's thought of everything. Although our source did mention another big benefit, scalability. How does Docker handle scaling applications up or down when you need to? So scalability. How's Docker help with that? Seems pretty important these days. Apps need to handle, like, huge spikes in traffic.
Totally. Imagine launching a game and suddenly 1 million people are trying to log in.
Right. Chaos.
Docker makes it manageable, though. Remember our container ship analogy?
Yeah.
Think of them as parts of your application. One ship gets overloaded, you just add more ships, right? Distribute the load.
Okay, so more ships, more cargo. How does that translate to software?
It's kind of similar, actually. With Docker, if your app gets slammed with traffic, you can spin up more containers of that application. Handle the extra load. Each container is independent, so they can be spread across servers. Makes your application way more resilient, more scalable.
Wow. Like an army of mini apps ready to go at a moment's notice. That's going to be huge for businesses, being able to scale so fast.
For sure. And it works both ways. As easily as you scale up, you can scale down when things quiet down. That flexibility is another reason Docker's perfect for cloud stuff. You only pay for what you use, and Docker makes it easy to, adjust on the fly.
An army of tiny, adaptable helpers.
Yeah.
I like it. So we've covered a lot. Containers, images, Docker Hub, the benefits, CI/CD, scalability. But for someone hearing all this for the first time, what's the big takeaway? Why should they care about Docker?
Good question. I'd say the big thing is Docker makes software development better. Faster, more efficient, more reliable. Developers can build and ship better apps with way less hassle.
And do it all while being more efficient with resources and making apps more scalable. Sounds like a win-win-win to me.
It is. And we're just scratching the surface here. You dig deeper into Docker, you'll find even more powerful features, more use cases. It's a versatile tool, no doubt. Really changed how we think about software.
It's pretty amazing.
Yeah.
A simple idea like containerization completely revolutionized an industry. Kind of like our source said, Docker didn't just change how we build and ship software. It changed how we think about software.
Yeah, and that's the great thing about technology, isn't it? Sometimes the simplest ideas have the biggest impact.
Definitely. And on that note, I think we've given everyone a lot to think about. For anyone who wants to dive in even further, we'll link some resources in the show notes.
Absolutely. Happy coding, everyone.